Hello students, welcome to Educate. In the previous videos, I have discussed about the chemical kinetics and have solved some questions which was based on the basic concept, that is what actually is the rate of reaction. Now we will discuss here the factors influencing rate of reaction. So that means on changing any condition, what will be the effect on the rate of reaction? About that we will discuss. Let's see here. First one is dependence of rate on concentration. So what will be the change in the rate of reaction on changing the concentration of reactant? Actually, there will be change in rate of reaction according to rate law expression. There will be change in rate of reaction on changing the concentration of reactant according to rate law expression. Okay, what is rate law expression? Let's see. Suppose a balanced chemical equation is 3A react with B to give 2C plus D. Suppose a hypothetical reaction it is. This reaction is a hypothetical reaction in which 3A react with B to give 2C and D. A hypothetical balanced chemical equation is. We usually balance the chemical equation, and that is based on the law of conservation of mass. That means during a chemical reaction, the mass will not destroy nor produce. That means during a chemical reaction, the total mass will remain constant or conserve. Means that will not destroy nor create. So here balancing, this is a balanced chemical equation. Now we determine the rate law expression by doing the experiment. Suppose here is, this is a vessel in which A react with B. Obviously there will be a formation of C and D. The rate of reaction we can predict by changing the concentration of C as well as that of D. Firstly, what we did, we firstly keep the concentration of B constant. That means in this reacting vessels, there will be some particle of A and some particle of B. Reaction is taking place. Now we have added here A we have added. So the concentration of B remain constant because the number of particles of B has not been added in this one, in these vessels. Only we are adding the reactant A, and it observed that the rate of production of D has become twice. We have increased the concentration of A through 2 times, and we find out that the rate of production of D has become 2 times. That means rate of reaction here is directly proportional to concentration of A. Now we also verify that what we are thinking, that it is correct or not. Then again make the concentration of A 3 times, and it has been observed that the rate of production of D has also become 3 times. Firstly, have made the concentration of reactant A 2 times and the rate of reaction has become 2 times. Again make the concentration of reactant 3 times and the rate of reaction has also become 3 times. Now make the concentration of reactant 4 times and the rate of reaction has also become 4 times. So what happened here? We can say the rate of reaction is directly proportional to concentration of A. Rate of reaction is directly proportional to concentration of A. Now, in another vessels, same reaction, A react with B and forming C and D. So now, keep the concentration of A constant and change the concentration of B. Make the concentration of reactant B, and it has been observed that the rate of reaction, make the concentration of B 2 times, and we have observed that the rate of reaction has also become 2 times. Again, we have increased the concentration of B and make the concentration of B 3 times, rate of reaction has become 3 times. Now again, make the concentration of reactant 5 times, rate of reaction also became 5 times. So here we can also say that the rate of reaction is directly proportional to concentration of B. So rate of reaction is directly proportional to concentration of A into concentration of B. Balanced chemical equation here is 3A plus B, that gives this one. So balanced chemical equation is different, but rate law expression is different. Rate law expression is based on doing the experiment. What be the rate of reaction on changing the concentration of reactant A and the reactant B. That is the rate of reaction, this one. If we remove the proportionality sign, so we will have to keep a constant, that will be K into concentration of A into concentration of B. This K is called rate law constant. Rate law constant. Okay. What will be the order of reaction? So here there is power of 1, here power 1. So order of reaction, that will be equal to 1 plus 1, that is 2. So what will be the effect on the rate of reaction on changing the concentration of reactant? That will be based on rate law expression. Okay, and what is rate constant? This one. Take another hypothetical reaction. 2A react with B and there is formation of 3C plus T. It has been found that now in the reacting vessels A here, keep the concentration of B constant. That means don't add B, add A. You have made the concentration of reactant 2 times and it has been observed that the rate of reaction has also become 2 times. Now make the concentration of reactant A 3 times and the rate of reaction. Now listen here, leave that. There is A and B, reactant A and B, and you have fixed the concentration of B. Now make the concentration of reactant A 2 times and it has been found that the rate of reaction has become 4 times. That means when you have changed the concentration of reactant A through 2 times, the rate of reaction has increased by 4 times. Now make the concentration of reactant 3 times. The rate of reaction will become 9 times. So through what you are changing, rate of reaction is increasing by the square of the concentration of A. So what happened? We can say that rate of reaction is directly proportional to concentration of A, that's a square. Now do another experiment. Now keep the concentration of reactant A constant. Now watch out the effect of change in concentration of B on the rate of reaction. What happened? You have made the rate of reaction concentration of B 2 times, but there will be no change in the rate of reaction. Now you make the concentration of B 3 times, but there will be no effect on the rate of reaction. So that means here we can say that rate of reaction do not depend on the concentration of B. So rate of reaction will be directly proportional to concentration of B to the power 0. So rate of reaction, that will be directly proportional to rate constant into concentration of reactant A, that too. Oh, that means here rate of reaction will be equal to rate constant into concentration of reactant A to the power 2. So here order of reaction that is equal to 2. Just like that, guys, if you will do watering in the water more, that not means that there will be increment in the length of the plant. But without water, there will be no growth of the plant, you already know. So that is here, that is zero order reaction, means on changing the concentration of reactant, the rate of reaction will not change. Okay, so that is here. Now let's see, we proceed here. Based on this one, there is numerical question we will discuss later on. Here what is given here, that's watch out. Rate law is the expression in which that is rate law equation. So here it has been stated that in this statement that the rate law expression may be same or may be different from stoichiometric coefficient of the reacting species. Okay, so that is here. I have told you balanced chemical equation is different and that of rate of reaction is rate law expression is different. That may be same, may not be same. Okay, balanced chemical equation is based on the law of conservation of mass, while the rate law expression is based on the experiment. Okay, based on that, there is a question. You watch out the last portions of this chapter. There is an important question about which we should discuss, because that type of question has been frequently asked in IIT as well as in NEET examination, and most frequently that question was asked in AIEEE. So when that question was asked in AIEEE, so there is high chances of asking that question in IIT main. So we will discuss about those questions there. Here in this one case, watch out. Watch out this question here. So here it has been chart A and B here. That is the concentration of reactant and the product has been given, and what's the effect on the rate of reaction, that has been given here, and it's asking the order of reaction you will have to find out with respect to A and B. So how to solve? Let's see. Here concentration of A 0.2 and here 0.2. That means In this case, concentration of reactant has not changed. Here, by this new data has been provided when the concentration of reactant has not changed. So, what's the effect on the rate of reaction? Rate of reaction also has changed. Here, not change. So, what is here? So, concentration of B is 0.3, 0.1. So, either you do 0.3 upon 0.1 that to the power x. You don't know what's the order of reaction with respect to B. So, concentration of B is 0.3 upon 0.1 I have taken. So, we will have to take this data upon this data. So, 0.3 upon 0.1 to the power x, that will be equal to 5.07 into 10 power minus 5 upon 5.07 into 10 power minus 5. That is here mole per liter per second. Given or not? Yes, mole per liter per second, that is unit is here mole per liter per second. So this one is 1 and 3 to the power x is equal to 1 here, and that is possible only when x will be equal to 0. Anything to the power 0 that is equal to 1. So that means x equal to 0. So rate of reaction here is directly proportional to concentration of B to the power 0. So when the rate of reaction does not depend on the rate of reaction does not depend on the concentration of the reactant B, then any value we can take. So here we are taking here this one. So you can write here 0.2 upon 0.4 to the power x equal to this upon this. Either this upon this to the power x will be equal to this upon this, or this upon this to the power x equal to this upon this. So for the sake to make the questions easy, to make the calculation easy, I am doing like this. 0.4 2 to the power x equal to how much? Just watch out. 10 power minus 5 will go in the numerator. So that become 10. So that will be here 14. That will go. So 14.3 upon 5.07. Watch out here. So 1.43 into 10 power minus 4, that upon 5.07. 5.07 into 10 power minus 5. That is so that will come 2.82. That is 2.82 or nearly about 3. Okay. So 2 to the power x equal to 3. So what here? 2. So to calculate this one, how you to log 2 to the power x equal to log 3, x log 2 equal to log 3, x into log 2 is 0.314, that equal to 0.4, x equal to 0.4 upon 0.314. Like that you can calculate. Okay. So put the watch out the value of log 3 nearly. So I have calculated here in rough manner. That is the manner to calculate. Here, if you will not get in the examination, what the value here to the power x equal to 3 you have calculated. So how to calculate? So you will have to take log both sides. So log 2 to the power x equal to log 3. Now log 2 to the power x equal to x log 2 because log a to the power x equal to x log a. The same here, x log 2 is 0.312, 314, whatever be that. This one. So roughly I have taken here, and log 3 0.412 here will be there, 412, and then after 0.412 upon 0.314. What will be the answer? That's to find out. So you consult the log table. Now, second question, watch out. The following have been obtained during the recalculation. This one. So first or second question here, watch out here. So if you will have to calculate the rate law in terms of B, so here is 0.3, 0.3. This one is constant. So either this upon this, then this upon this will be. So 0.4 upon 0.2, that to the power x equal to 2.88 into 10 minus 1, that upon 7.2 into 10 power minus 2. Because this one is constant, so this upon this will be equal to this upon this to the power x will be equal to this upon this. So that will become nearly 0.4 divided by 0.2. So that is here 2 to the power x, that equal to here, and 10 power minus 2 will go in the numerator, so that will become 10 here. So 2.88 into 10, that upon 7.2. Calculate that. So that will become 4. So 2 to the power 2 equal to, that can be also written as 4 can be written as 2. So 2 to the power x equal to 2 to the power 2. So x equal to 2. So rate law expression in terms of B is 2. So rate of equation will be directly proportional to concentration of B to the power 2. Now in terms of A, calculate rate of reaction in terms of A will be what? So here, so in which equation, here is 0.1, here is 0.1. So at this one, concentration of B is constant. So we will have to consider about what will be the effect on the rate of reaction on changing the concentration of A. So here concentration was 0.4 and here was 0.1. So to calculate the easily, I am taking 0.4 upon 0.1, that to the power x will be equal to 2.40 into 10 power minus 2, that whole upon 6 into 10 power minus 3. So that will be equal to here 24 upon 6. That will be 4. So now this cancel out. 4 to the power x equal to 4. That means x equal to 1. So rate of equation is directly proportional to concentration of A. Now rate law expression will be, rate law will be, that will be concentration of A into concentration of B, that's square. Now how to find out rate constant? Second question is rate constant. So let's see how to calculate the rate constant. Take any question like this one. So rate constant, rate of reaction is 6 into 10 power minus 3. That is equal to this one, rate constant into concentration of reactant, how much? Concentration of reactant here 0.1. So 0.1 into 0.1, that's a square. So that means 6 into 10 power minus 3, that much mole per liter per second will be equal to, here 0. Here that means you can write 10 power minus 1. So 10 power minus 2 here, and here 10 power minus 3. So K into 10 power minus 3. Mole per liter, here mole per liter. That you consider by yourself. Here is mole per liter, and here mole square per liter square. So mole to the power 3 here, and liter to the power minus 3. So this side come, so K will be equal to 6 into 10 minus 3 mole per liter per second, that whole upon 10 power minus 3 mole cube liter to the power minus 3. So 3 this cancel. That is, rate constant will be 6 mole to the power minus 2 liter square into second inverse. That was rate constant. Okay guys, question was easy, but this question frequently asks in NEET examination as well as in 12th board examination. And there is high probability of asking this question in engineering examination of state level. Okay, now let's see third question. So here the reaction is, the rate of reaction is first order in terms of A, and zero order with respect to B. Zero order with respect to B means whatever you change the concentration of reactant B, there will be no change in the rate of reaction. It is first order reaction. So watch out here, this one and this one here, fill up. So rate of reaction has become 2 times here. So concentration will also become 2 times. Now here 0.4 here make. So from here and here, concentration has become 2 times. So rate of reaction will also become 2 times. So that will be 8.0 into 10 minus 2. Now here and here you have to find out, here and here. So 0.4 and here this one. So 2 into 10 minus 2 here. So that will be 0.1. This reaction is 1/4 of this one. Rate of reaction became 1/4. So concentration of reactant will also become 1/4 because the reaction is first order in terms of A. Okay. These questions were very easy. You can solve these questions very easily. There will be requirement of the concepts or the confidence only. Okay. Then after this here, how to calculate the unit of rate constant. And guys, a number of times question has been asked in NEET examination as well as in the AIEEE examination. So related to this one, so we will have to take these questions very seriously. About that one we have discussed. Now let's see. Calculate the overall order of reaction. Which of the has this one? Order of reaction you will have to find out, and rate law expression has been given. So this one is too much easy as we have discussed here. So 1/2 plus 3/2. That will be. What is the order of reaction? In the 12th board examination, question asked in 1 marks. What is order of reaction? So order of reaction, that is sum of the powers of the reactant, the sum of the powers of the concentration of reactant in rate law expression. That is called order of reaction. Order of reaction is the sum of the power of the concentration of reactant in rate law expression. Either you write like that, or if you have the tendency to get mug up, then you may write this one. Same concept which I have told you, that is definition also. So either you write in your own word or directly write this. Now, this one very easy. So here 3/2 minus 1. So that will be the order of reaction. Very easy it is. Then after is, what is elementary reaction and what is complex reaction? The elementary reaction is the reaction in which elementary reaction is the reaction in which reaction which takes place in a single step. The reaction which takes place in a single step, that is called elementary reaction. And complex reaction is the reaction which takes place in more than one steps. That will be called complex reaction. Elementary reaction is the reaction which takes place in a single step, and complex reaction are the reaction which takes place in more than one step. In a complex reaction, the slowest step will be the rate determining step. Just in case of chapter haloalkane and haloarine of organic chemistry, in chapter of haloalkane and haloarine, you might have studied, or if not studied, then you will study about the SN1 reaction mechanism and SN2 reaction mechanism. I am giving you here the information related to that. What is SN1 mechanism, or what is SN1 reaction mechanism? What is that? The name indicates SN1. That means the reaction in which the rate of reaction will depend on the concentration of only one reactant, that is haloalkane, and will not depend on the concentration of nucleophile. That will be called then it will be said that the reaction takes place through SN1 mechanism. When the rate of reaction will depend on the concentration of haloalkane and will not depend on the concentration of nucleophile, then it will be said that the reaction takes place through SN1 mechanism. Okay, let's see here about that one also. What happened in step 1? That means there is 2 steps. SN1 reaction mechanism takes place in 2 steps. So step 1, what happened? Like this haloalkane, first of all, there will be cleavage of carbon-halogen bond. There will be firstly cleavage of carbon-halogen bond, and the cleavage of carbon-halogen bond is a slow step. So what happened? This process will take place slowly, and there will be cleavage of carbon-halogen bond and haloalkane form and halogen chloride ion form. Okay. In the next step, what happened? Here positive charge is carbocation and the nucleophile will approach. With here you may attach here this one. Okay, nucleophile will approach toward this methyl. So there, and this step will be a fast step. So there will be formation of this one. So now this one is a step 1. Step 2 will be step 2. In step 1 there will be cleavage of carbon-halogen bond and formation of carbocation. In step 2 the nucleophile will attack on the carbocation and there will be formation of carbon nucleophile bond here. So this step is a slow step, this step is slow step, and this step is fast step. In the slow step, there is involvement of only haloalkane. That's why the rate of reaction depend on the concentration of haloalkane and do not depend on the concentration of nucleophile, because the involvement of nucleophile is in the fast step. Okay, that was the complex reaction. Now, unit of rate constant, that's asked frequently. What, in which form? In 12th board examination nowadays has been starts asking, and in NEET examination that asks very frequently. What is the unit of rate constant? So let's see. In case of zero order reaction, you can calculate by here also, or some students mugged up what's the unit of rate constant in zero order reaction, first order reaction, as well as in second order reaction. So let's see. Firstly, unit of rate constant. Firstly, find out the unit of rate constant in zero order reaction. You already know the rate of reaction here will be equal to K into concentration of reactant to the power 0. So unit of rate constant, unit of rate of reaction will be equal to unit of rate constant into concentration of reactant to the power 0. Concentration of reactant to the power 0 equal to 1. So here unit of rate of reaction will be equal to unit of rate constant, and unit of rate of reaction is mole per liter per second. So that will be the unit of rate constant. So in zero order reaction, the unit of rate constant will be mole per liter per second. Let's see first order reaction. You already know in first order reaction, the rate of reaction, this is the expression of rate law expression, R equal to rate constant into concentration of reactant. Now concentration of reactant, that will be mole per liter, and concentration of rate unit of rate of reaction will be mole per liter per second. Unit of rate of reaction will be mole per liter per second, and unit of concentration is mole per liter. So what will be here? So mole per liter, this will come here. So mole per liter will cancel out, and that will be second inverse. And among these three, frequently asked question is about first order reaction. More frequently, that what's the unit of rate constant in first order reaction? And actually question in NET examination not asked in that form. There will be given, there is a reaction in which the value of rate constant is that much. Unit will be given. That means 5 into 10, 5 second inverse, 5.0 into 10 power minus 3 second inverse. What is the order of reaction? So students who have the tendency to mug up the formulas will think about the formulas, but actually what is here? No need to calculate, simply watch out the unit of rate constant, and based on that the reaction will be either first order or second order or zero order. That was. Now so let's see about the second order reaction. Unit of rate of reaction is mole per liter per second. That will equal to unit of rate constant into here mole, and unit of concentration is mole per liter, that's a square. So it will be mole square per liter square. So unit of rate constant will be mole per liter per second, that upon mole square per liter square. Mole square will go in the numerator, that become mole inverse, and later that will become liter second inverse. So in zero order reaction, the unit of rate constant will be same as that of rate of reaction, and that is mole per liter per second. The unit of rate constant in first order reaction will be second inverse, and that in the unit of rate constant in first order reaction will be second inverse, and that in the second order reaction will be mole inverse liter per second. Okay guys, very easy to solve this question. Let's see here. And who have watched this one question bank, he may realize that this type of questions has asked in the 12th board examination a number of times, and who have watched the questions of NEET examination and that of the IIT main, he will also realize that this type of question has been asked. In IIT main examination, not so much, because that's the use of this one, because if there was the use of this concept, and in NEET examination has been asked directly, and in 12th board examination this type of question was asked directly. Let's see here. This one is unit, so obviously this unit is for second order reaction, so it will be second order reaction. This one is second inverse, this is for first order reaction, so here this reaction is first order reaction. Okay guys, I hope you have felt these concepts easy. So in this chapter we have discussed about the order of reaction, and based on that which type of questions frequently asked in 12th board examination as well as in NEET examination. But in main examination here, that means which we have discussed, that has been not asked directly, but the concepts related to this one, that means these topics, when you was used to solve the questions of IIT main. That means there was few questions has been asked which you can solve only when you will have the concepts related to this topic. Okay, in the next class we will discuss about the molecularity of reaction. Today it's all for this class. Thank you, Team Educate.